Charge number or valence of an ion is the coefficient that, when multiplied by the elementary charge, gives the ion's charge. For example, the charge on a chloride ion is, where E is the elementary charge. This means that the charge number for the ion is sometimes used as the symbol for the charge number. In that case, the charge of an ion could be written as, for an atomic nucleus, which can be regarded as an ion having stripped off all electrons, the charge number is identical with the atomic number Z. In particle physics, the charge number is a flavor quantum number, mostly denoted by Q rather than Z. For color-charged particles with like quarks and hypothetical leptoquark, the charge number is a broken multiple of 1/3. The charge number in chemistry normally relates to an electric charge. This is a property of specific subatomic atoms. These elements define the electromagnetic contact between the two elements. A chemical charge can be found by using the periodic table. An element's placement on the periodic table indicates whether its chemical charge is negative or positive. Looking at the figure below, one can see that the positive charges are on the left side of the table and the negative charges are on the right side of the table. Charges that are positive are called cations. Charges that are negative are called anions. Elements in the same group have the same charge. A group in the periodic table is a term used to represent the vertical columns. The noble gases of the periodic table do not have a charge because they are non-reactive. Noble gases are considered stable since they contain the desired 8 electrons. The other atoms or ions have charges because they are very reactive and want to react with another atom or ion to become stable. When elements are bonded, they can either be bonded by ionic bonding or covalent bonding. When elements bond between positive and negative charged atoms, their charges will be switched and carried down on the other element to combine them equally. This is shown below. Using the chart provided, if ammonium with a +1 charge is combined with an acetate ion with a -1 charge, the charges will be cancelled out, shown in the figure below. NH_4 caret ++ C_2H_30_2 caret NH_4 C_2H_30_2. When two ions are combined with different charges, the charges do not get cancelled out. They get carried over and placed at the end of the other ion. This is shown below between ammonium and carbonate. NH_4 caret ++ CO_3 caret _2 CO_3. The ammonium part on the product side has to have parenthesis in order to distinguish between the ammonium subscript 4, compared to the 2 charge that has been dropped down, connected to it. NH_4 caret ++ C_2H_30_2 caret NH_4 C_2H_30_2. When two ions are combined with different charges, the charges do not get cancelled out. They get carried over and placed at the end of the other ion. This is shown below between ammonium and carbonate. NH_4 caret ++ CO_3 caret _2 CO_3. The ammonium part on the product side has to have parenthesis in order to distinguish between the ammonium subscript 4, compared to the 2 charge that has been dropped down, connected to it. Charge numbers also help to determine other aspects of chemistry. One example is that someone can use the charge of an ion to find the oxidation number of a monatomic ion. For example, the oxidation number of Li caret plus is +1. This helps when trying to solve oxidation questions. A charge number also can help when drawing Lewis dot structures. For example, if the structure is an ion, the charge will be included outside of the Lewis dot structure. Since there is a negative charge on the outside of the Lewis dot structure, 1 electron needs to be added to the structure. If the charge was positive, an electron would be lost and taken away.